But we are going to prove the proportionality theorem here. But before we do that, I want us to discuss a few things. Right, let's look at these triangles. We have triangle ABC there. If you check also, we have triangle ADE. If you check also, we have triangle BDE. We have triangle CED. Those are the triangles that we have there. Let's talk about those triangles. Right, if AD is the base of triangle ADE, this triangle, okay, what is the height of this triangle? If AD is the base, what is the height? The height is going to be, or it is K. The height is K. But if you check, if the base is AE, the height was going to be H. But we're going to talk about that just now, very soon. Right now, what about triangle? If you check triangle BDE, if DB, if DB is the base of triangle BDE, this triangle, what is the height of this triangle? What is it? It is K again. Do you see that? It is K. The height is just outside the triangle. We talked about this, okay, in the previous lessons. Right, and then now you can see that the height is K, and we can see that triangle ADE and triangle BDE have a common height K. So we've worked on the side on the left of the triangle. Now let's look at the when the bases are on the right. When the base is AE for triangle ADE and the base is EC for triangle CED. Okay, right. Take your time and try to understand this because we're going to use this in our proof. Right, let's go to the right hand side now. If AE is the base of triangle ADE, what is the height of this triangle? If AE is the base of triangle ADE, what is the height of the triangle? The height of the triangle is H. Okay. And then if EC is the base of triangle CDE, what is the height of the triangle? EC. See, EC is the base of the triangle. What is the height of this triangle? It's base of triangle CDE, this triangle. What is the height? You see that the height is H outside the triangle. Remember, we can have triangles like this. Okay, where we have a triangle like this. This is a triangle. Let's say A, B, C, and then the height is outside the triangle like this. You see, that's the situation there. So the height is equal to, sorry, is outside the triangle. So the height of triangle is CDE there is H. Okay, right. And then now we go to, oh, right, we have recognized that triangle ADE and triangle CDE have a common height H. Okay, right. So we're going to use this as we're going to be proving our proportionality theorem. Let's go to the proof. Right, this is an examinable proof that you have to know. Right, in triangle ABC, D lies on AB, can see there, and E lies on AC, and DE is parallel to BC. Now, we are required to prove that AD over DB is equals to AE over EC. We have to prove that AD over DB is equal to AE over EC. Let me just highlight that. We are saying AD over DB, which is this, AD over DB is equals to AE over EC. You see that we want to prove that. And then the construction we have to do. We draw what? We draw the latitudes H and K. We discussed these latitudes, the heights you just discussed them now. For the altitudes of triangle ADE relative to bases AD and AE, and then we join DC. Okay, right. Let me say it again. At construction, we draw altitudes H and K for the altitudes of triangle ADE relative to the bases AD and AE. And then after that, we join DC and BE. You can try to do these things before I show you. All right, let's start. Now we're going to draw the altitude here, which is H. You see that? That's the height of triangle what? Of triangle ADE. If the base is AD. And then if the base is AE, it means the height is going to be like this. You see that? If the base is AE, then the height is going to be K. All right, that's the first step. Then we join DC and BE. Join DC and BE like that. So now we've created other triangles there. Triangle BDE and triangle CDE. If you check, okay? You can pause here and take your notes. Right, now consider triangles with bases AD and BD, these ones, and the height is what? We say their height is what? Is H. You see that? Their height is H. And then remember, what is the area of a triangle? It's half times base times height. So meaning that the area of triangle ADE, the blue triangle, the bluish triangle, is equals to be half times base, our base is AD, times height, which is H, over the area of triangle BDE, the brownish triangle, and then it's going to be the area is going to be half times base. The base is DB. Can you see that? And then the height again is H. And then if we say H divided by H, we get 1. Half divided by half, we get 1. Then we remain with area of triangle ADE divided by area of triangle BDE is equals to just AD over DB. Okay, you can pause here and just take your notes. Right, and then we come to the other side. You still have triangle ADE there, but the height now, if the base is AE, the height is K. So we're going to say the area of triangle ADE over the area of triangle CDE is going to be half times AE times K, and then the area of triangle CDE is half times EC times K. Okay, and then if we divide here and say half divided by half is 1, K divided by K is 1, we remain with AE over EC. So the area of triangle ADE divided by the area of triangle CDE is just equals to AE over EC. Again, you can pause here and take your notes. So we have two things now. We have concluded, we have this. We say that this area of triangle ADE divided by area of triangle CDE is equals to AE over EC, isn't it? And then here we have area of triangle ADE divided by area of triangle BDE is equals to AD over DB. But if we check these two triangles, triangle CDE, triangle CDE, and triangle BDE, they have the same area. I want you to pause here and check and see why I'm saying triangle CDE and triangle BDE have the same area. Can you check that? Why do they have the same area? Because they have the same base. If you check here, okay, they have the same base. We say the base is DE there, okay, and they are lying between parallel lines. Let's say the height between the parallel, which is just the same like this. Okay, let's call it just H also. Right, the height of these two triangles will be H, and then the base DE there is the same. So the area of these two triangles is going to be the same because they have the same base, which is DE, and they have the same height since they are lying between the parallel lines. So the areas here of these two triangles, CDE and BDE, are equal. Okay, the area of triangle BDE is equal to the area of triangle what? CDE. Okay, so meaning that this is just the same as this. Since this area is the same as this area here. And then if you take the numerators are just the same, it's area of triangle ADE here, and then it's area of triangle ADE there. So if these two, the areas I've highlighted with red and green there, if they are equal, therefore these two statements are equal. We're saying that the area of triangle ADE over area of triangle BDE is equals to the area of triangle ADE over area of triangle CDE. And remember what we said. This is the area of triangle ADE divided by area of triangle BDE. And then again, we have this one here as the area of triangle ADE divided by area of triangle CDE. So we can replace this with these two. You see that? So we can say that, therefore, AD over DB is equals to AE over EC. Okay? It's a bit challenging, but you have to try. You keep on trying, repeating, replaying the video until you understand it, till you can do it on your own. Okay, right? You cannot understand it once, you have to keep on reminding yourself. Okay, right. So now from this, we can come up with the corollaries. So we can conclude and say now AB over AD is equals to AC over AE. These are the corollaries that you have to know. Okay, right. So AB over AD is equals to AC over AE. We can also say AB over DB is equals to AC over EC. And then we can say BD over DA is equal to CE over EA. And the last one, BD over BA is equals to CE over CA. So those are the four corollaries you have to know. Okay, right. I hope you managed to learn something. Keep on revising till you understand it. Right, so now we have said that a line drawn parallel to one side of a triangle divides the other two sides proportionally. So the reason we write say line parallel to one side of triangle or proportionality theorem, and then you name the parallel lines and say DE parallel to BC in this case. Right, and then if a line divides two sides of a triangle in the same proportion, then the line is parallel to the third side. And then we can write as a reason, line divides two sides of triangle in proportion. Okay, thank you very much. Welcome to meet in our other lessons.